So just a real quick review because we should probably know all this by now. We're going to look at the angle relationships formed with intersecting lines. So in the first two up here, these can be any pair of intersecting lines, and if we have the two angles next to each other formed at the intersection, linear pairs, those are always supplementary. It means adds up to 180. Vertical angles are like opposite each other on intersecting lines, and these are always congruent. Now, these next four are all based on the lines being parallel to each other. So alternate interior angles, like that, are congruent as long as the lines are parallel. Alternate exterior are also congruent when the lines are parallel. Corresponding angles are congruent when lines are parallel, and same side interior angles are supplementary. So same side supplementary is very helpful to help you remember that. Now here's the type of diagram where you are definitely going to see these things. So what we have here are two triangles that meet at a point P in the middle, and we know that this side TR is parallel to this side SQ. So there's a lot of things that come out of this. Number one, we see vertical angles. These pop up anytime we have this little X right here. And by the way, I usually like to call this the bow tie diagram, or the hourglass, if you think of it this way, because this pops up all the time. So with this, the red ones, we have vertical angles. Vertical angles that are always congruent. So we have angle RPT is congruent to angle SPQ. Whoops, I forgot angle. Let's try again. Angle SPQ. There we go. And then what also pops out of this is if you focus, like if you think of this as parallel lines, then we have a transversal right here, TQ, then what it means is that angle T is congruent to angle Q. Angle T congruent to angle Q because they're alternate interior angles. And alternate interior angles are always congruent when the lines are parallel. Now, you might be thinking to yourself, what if I used these parallel lines, but I used RS as my transversal instead? Well, that's very astute of you because these angles, angle R and angle S, are also alternate interior angles. So if you have a little bow tie diagram like this, and it tells you that these lines are parallel, what you know is that all three of these angles are guaranteed congruent to the other three angles because we have vertical right here at the intersection, and then we have alternate interior here and alternate interior here. So in order to prove these two triangles congruent, all you need to know is that one of these sides, like TP and PQ, or PS and RP, or TR and SQ, just one pair of sides is congruent, and then automatically you know that these two triangles are congruent by either angle side angle or angle angle side.